And just saying welcome everyone, and thank you for another seminar on this special series with Kim. We've been a couple of months, right, Kim? This is the second last in this very special series for business innovation, system dynamics and business innovation. This is the 8th webinar, and we have another one in 2 weeks. And today we're going to talk about dynamic business models in systems engineering. So I hope that we get to understand how these dynamics models are connected to systems engineering in the terms and topics in systems engineering. And I want to just give a big thank you to all society sponsors. It's only through their help that we're continuing able to spread the word about system dynamics globally. If you would like to start to sponsor the System Dynamics Society, we can start a conversation. You can email me at office@systemdynamics.org and talk to me and Rebecca about sponsoring the society. If you joined us before, you may know that we are offering a certificate for those who attend at least 6 of webinars in this special series. So you can take note of this one. If this is the first one you're attending, you can join the society and watch the recordings from the previous ones. They're all available in our website. If you're already a member, they are available on the systems business special series in the page. I can put here in the chat very soon, so you can get all the recordings and watch and get your codes and then request your certificate. And today we're gonna have about 45 minutes presentation from him in a 20 minutes Q&A session. You can send your questions in the chat. And I'm just gonna mute people here. And I'm gonna brief introduce you to Kim. For those who don't know him yet, he's a very experienced business professional and academic. He spent over a decade in senior roles on his expertise in business strategy. He taught at London Business School for 20 years, focusing in system dynamics, and he has authored important books in the field and won the J.W. Forrest Award, which is one of the highest awards in the system dynamics field. And he was the president of the System Dynamics Society back in 2013. And he has also developed a range of learning materials and courses to disseminate the strategy dynamics method, which he applies here in these webinars and show us. So Kim, thank you so much for another webinar in this very special series. I think this is all from my side. Looking forward to hear your talk today.
Oh, thanks, Fernando, and hello, everybody. Let me just share the screen and make sure that's going to work okay for everybody. Find the right screen first. There we go. How's that? All good, I hope.
Yeah, I can see your screen.
Cool. Okay. Right, let's dive in then. So this session is about the support that dynamic business models that we can build with system dynamics can offer for systems engineering. And this comes from several years of talking with various people in COSI, which is the Professional Society for Systems Engineering. If we have senior business leaders following this, they probably already know that systems engineering is something that can help with engineering type issues and challenges, designing factory systems and supply chains and managing big complex projects and so on. But it can actually do more than that, and the systems engineering field itself is trying to push out into helping management with more kind of enterprise-wide issues, dealing with things about how the organization actually works, as well as pure kind of physical engineering challenges. So for any systems engineering professionals who might be listening to this, you should get a sense from this talk about how system dynamics models offer something which is now kind of at the heart of systems engineering. Model-based systems engineering is the slogan now that people in the field follow. and how that can help with tackling enterprise issues. Now, I should say before I go on that there are people in the system dynamics field who are professional systems engineers, and they know much more about systems engineering than I do. That's why I'm going to limit what my contribution this afternoon to talking about those implications for enterprise issues, not at all about kind of engineering project applications for systems engineering. So this is what we're going to cover. I'm going to explain a little bit about that systems engineering as it may be thought of for helping with enterprise level issues. I'll give a demo of a simple project challenge, and that is more oriented to people who are not already system dynamics experts. It kind of shows people who are not system dynamics experts what these things can actually do. And then we'll kind of reflect on what that implies for what dynamic models add to systems engineering efforts. And I'll finish off with a few next steps that you might like to consider after this seminar. So let's dive into that first topic. So here's a definition of one of thousands, probably, of systems engineering. We use systems engineering for the understanding, creation, use, and sustainment of engineered systems to enable the realization of stakeholder needs. So that's really very, very broad. But that phrase, engineered systems, kind of implies, in most people's heads, kind of physical systems or IT systems, those kind of things. But the organizations we work in, the enterprises we work in, whether they're in business or in non-profit settings, they are engineered systems as well. We designed the organizations to function the way they do and to deliver the results in the way that we hope that they will. So engineered systems is much more than physical systems or IT systems. So historically, there's been a vast range. I don't know how long the systems engineering field has existed. It must be over 50 years, I guess. But over its history, it's tackled a vast range of engineered physical systems, product development, huge projects, supply chain, manufacturing. They're all over the place. And nobody would seriously consider pursuing the development of an engineered physical system of those kinds without deploying systems engineering capabilities to design and test and implement those things. But recently and increasingly, systems engineers find themselves being asked to work on enterprise management issues. So how does the kind of non-physical parts of the organization actually work? How does the product development process work? How does the product launch process work? How does customer onboarding work? It's a whole load of other things than physically engineered. And you'll find much more about. There's this thing called the Systems Engineering Body of Knowledge, or CBOK. If you look that up or follow this link in the slides at the end, that will take you to considerable definitions about all the stuff that lies behind what I'm saying this afternoon. So the other trend that has happened now is this is kind of played out at the time we speak, whereas the kind of orientation towards enterprise issues is still kind of ongoing. But now the systems engineering field is very much kind of takes a model-based view. Now, prior to that, it was what might be described as kind of document-based approach to systems engineering, where you develop, test, deploy systems by creating and controlling the documents that keep the whole thing under control and everybody understanding what's supposed to happen when and so on. But really, I guess starting probably 20 years ago now, the field of systems engineering has moved very much to a much more model-based approach to systems engineering. So developing, testing, deploying systems with models that capture that system's behavior and capture how it functions and its physical characteristics. And you'll find much more on model-based systems engineering if you go to the link here called the MBSE initiative, which is in the it's kind of sponsored by INCOSE in conjunction with the IEEE. So once again, that's already well established, and we've got models for a vast range of engineered physical systems. There is a whole body of knowledge and certification and things that you need to know how to do as a professional system engineer in order to do model-based systems engineering of physical or IT or similar systems. So what we're looking at here is what's the potential for actually having a model-based approach to those enterprise level management issues. And as it turns out, that's been kind of meat and drink to people in the system dynamics field for 30 or 40 years. In fact, if we go way, way back to when Jay Forrester kind of founded the field of systems engineering, of system dynamics, sorry, the very first case that that caused him to come up with this method, this technology, this set of this theory, was an inventory problem, and it wasn't an inventory problem in the sense of, oh, you know, we've got an order chain and we need to control it better. That wasn't the issue. It was the issue of how you control that order supply chain when the marketing and sales part of the business was doing a whole load of other things, you know, changing prices and launching marketing initiatives and promotions and capturing new customers and all that kind of stuff. So right back at the start of system dynamics, the field was already connecting what's going on in the organizational parts of the world with that physical thing about how orders and goods flow through a supply, an order chain, an inventory chain. And so, as I say, this has been meat and drink to system dynamics for decades. So, where can simulation contribute to model-based systems engineering as it applies to enterprise issues? Well, it can help us plan and manage the development of the solution itself. So let's say, for example, that the business is planning to make an acquisition of another company and incorporate that company into its own operations. Then system dynamics and, well, a model, we would hope, would help us play out and simulate how that acquisition and integration process might play out. And again, I don't just mean, you know, how we crash together the production systems and the logistics systems. I mean, how do we merge the product ranges? How do we persuade the customers from the acquired business to stick with us now that we've taken over the business? How do we persuade the people who work for that business to stick with us? How do we rationalize the two organizations into a more effective, larger entity than before we made the acquisition? So we can plan and manage the solution before we actually get onto it. And then we can test and operate the solution itself. So once we've actually got the solution in place, we can manage that thing going forward. So we don't stop when we've modeled out how that acquisition might play out. We continue running the model all the way through and keep on updating how it's going to continue to fine-tune all the decisions and choices that we have to make during the whole what will actually be quite a long-term episode of making the acquisition of that other business. As I say, systems engineers already simulate physical solutions, and their simulations are massively sophisticated and complicated and do all kinds of amazing 3D visualizations and all that kind of thing. I'm sure we can do something similar with organizational issues and challenges, but I'll make the case this afternoon that we don't actually need to be quite that sophisticated and complex about it. So in our terms, in kind of business management and strategic management terms, the solution may concern any strategy, any challenge that we're taking on. A new competitors come along and threatens to take our market share away from us. any initiative that we're planning, like that acquisition I talked about. It could be a large one like that acquisition, or it could be something very small, like, we've got a problem with onboarding our customers and our customer support people can't cope. Well, that's a mingling of the onboarding process for the customers themselves and the development of the functionality of the thing that we're trying to sell to those customers. So we in System Dynamics, we deal with a huge wide scope of management and strategic challenges for organizations. Now, just backing off a little, System Dynamics is not the only tool that's used for this kind of thing. Of course, if you stop the average analyst or consultant in the street and ask them what they use for it, they'll tell you they use Excel. Well, sorry, it's just not fit for purpose. You can't solve the kind of multi-factor challenges that we're trying to deal with by peering at rows and columns of numbers in a spreadsheet. The spreadsheet itself might be able to cope with that, but the human brain can't. Okay, so we need something rather more sophisticated than that. And there are two other time-based simulation approaches: discrete event simulations, capture how items move through a system, and of course they've been all over the systems engineering field for 50 odd years, and every system engineer will know what discrete event simulations look like and have probably used many of them in their professional work. They may have moved on and started using agent-based modeling, which captures how autonomous entities interact. And both of those methods are extremely powerful tools if what you need to do, and you very often do need to do this, is to track what's happening at the entity level and in considerable time detail. So what's happening to every item in a warehouse as orders come in and orders get fulfilled, for example, what's happening to every entity at every moment in time in 3 dimensions. That you definitely need those kinds of simulation tools for that purpose, that kind of purpose. System Dynamics is, and this again is for newcomers to System Dynamics. It's got a kind of fundamentally different character, which it does not, is that it does not try to capture what's happening to individual entities. It captures what's happening to populations of entities. So what's happening to groups of staff, what's happening to broad numbers of orders, how many customers are being won and lost, how many products have we got in our product range, staff in various groups around the organization. We don't try and track each individual customer, each individual staff member, each individual product. We're simulating what's happening to broad populations of those. And obviously, you throw away some benefits of not knowing what's happening to every entity, but you get some really big benefits in return. And those benefits are that these models are very compact compared with agent-based and discrete event models. They're very quick to build, and they very easily handle all the different kinds of system elements. So a single model will handle what's happening to the cash in the business, the people in the business, the physical items in the business, the intangible factors in the business. Okay, so those are some benefits that SD offers as a trade-off for not being able to handle all of the individual entities. And there's a somewhat dated article here, but I think it's still okay. It will tell you a bit more about the relationship between these 3 styles of modeling. There's probably, I apologize for being a bit out of touch with the literature since I'm supposed to be retired. There may be some more recent publications on that same issue, but maybe if you go to Google Scholar and track that one down and find out where it's been cited, you'll find other more recent reviews of the 3 types of modeling. So let me give the non-system dynamics people who are on the call here a demo of a simple challenge. And this challenge is a project which is done by a group of staff. So we need enough staff to deliver the project, right? And the project has a number of tasks that have to be done. So what you're looking at here is how the number of staff on this particular project. It's a small project. It's going to run over 20 weeks. And you're looking at what's happening to changes to the number of staff. And in the blue scenario, the number of staff in the team is falling at a relatively steady rate of about 1 person per week. But we need it back up at least at 30 people if we're going to be able to complete this project in the time that we need it done in. And on the left of the diagram, you can see that we achieve this by raising the hiring rate to the team. And we're assuming for simplicity that the team simply keeps on losing 1 person per week for whatever reason. Now, there are two consequences. There are two dependent variables of interest here. One is how many staff hours each week can we deploy on this project, and that's at the top. But the other important issue is what do these people cost us, right? So what's happening to the total cost of that group? If this is all new to you, imagine that this diagram is sitting on top of a spreadsheet. It isn't, but imagine that it were. And that in that spreadsheet, every item you're looking at is a column in that spreadsheet with its name in the top cell and each period's values going down each of the 20 weeks for the model. And you can think of the arrows connecting things there as being like cell references. So there's a column headed total staff cost, and that is calculated from the values in the column headed staff and the other column headed cost per person in dollars per week. The advantage here, one advantage of our method here is that's exactly how you express the formula. It's not C17 equals A17 multiplied by $B $2 or anything of that kind, right? Where the items in the model are all expressed in natural language, and the relationships between them are all expressed in natural language. And there's a link you can follow after the webinar there, where you'll be able to go to this model, and the link takes you to a project of related models, which also cover the ones I'm going to deal with coming up. There's nothing to install, just go to the link and it will open in your browser. So the universal principles, which are very helpful to us in system dynamics, that follow it's a kind of summary of what is the theory that system dynamics is playing out for us, whatever field we're working in. The theory basically goes, we want to achieve some improvement in how some outcome changes over time. Okay, that's the objective of any model that we build. Part 2 of the theory is that performance depends at every period of time on a small number of items, among which are these things that accumulate over time. So that box of staff is an accumulating stock. It's filled up by the hiring on the left, and it's drained away by the lots of staff on the right. Those things that fill the stock are called flow rates. It's the rate at which a stock changes. So the next thing we need to know is, what do those flow rates depend on? Because everything else is already determined by the causality we've laid out here. And it turns out, which I'll show shortly, that the value of every flow rate in this structure depends on the quantity of existing stocks in that structure. And those 4 statements together summarize the theory for system dynamics. With those 4 relationships, you can build any system dynamics model. it also describes how the real world works, which is kind of helpful. Um, and what we've done is we've kind of bottled those 4 steps into an agile approach, an agile process for building these system dynamics models. There's an alternative approach which is very, very common. In fact, it dominates the field, where you start by sketching out causal loop diagrams, causal maps of how everything in a system is connected to everything else. And only then do you go on and try to quantify all that and formulate the relationships. This agile process doesn't do that. It starts from the outcome objectives that you're interested in and works back step by step, building out the model in tiny pieces. So you get a working model very, very fast. It's only a very small model, but you get a working model very fast, and you add each step, validating that as you go along. So now let's get those staff to actually do something. Okay, so at the top here, we've got this little project consists of a load of tasks that need to be done. And the project is completed when on the right-hand side, the stock of tasks that have been completed are done. Again, we've got the 2 scenarios. Each task takes some person hours to do. In the model as it stands, that's a constant number, but it could easily change. So every task could carry with it a different number of person hours to be done. And we've still got staff being lost at the right-hand end there, and we're adding something at the lower left, which is that we can only hire trainees. We can't add to the team people who already know what they're doing. We've got to hire trainees, and those people take some time to train. And staff cost money, including the unproductive staff. So you don't want a population of staff that includes too many people who are costing you money but not delivering work. And just at the bottom there, we are accumulating the total cost of the project. And once again, you can see we've got the 2 scenarios there, where in the first scenario, we don't try to rebuild the staff team. So the project is not even complete at the end of 20 weeks in the blue scenario at the top right. In the green scenario, it is complete. In fact, it's completed a little bit before week 20. So we end up fulfilling the time objective. That again is another model in the same link that I gave you before. So there is that principle 4 that I mentioned to you, which is that one of the flow rates in this model here, that's how fast we complete tasks, depends on the number of trained staff and existing stock. So if you go there, you can, when you get the slides down, you can have a go at the challenges which I'm outlining in this slide here. Change the hiring at any time you want, and see if you can minimize the cumulative cost of the project while still completing it within 20 weeks, or see if you can complete it within 15 weeks and how many staff do you need to do that. Or you might say, well, what would happen if we manage to make some process improvements and we don't need so many person hours to accomplish the project, and maybe it takes less time to train people. Okay, obviously, any real world project, there are many more complications here. For example, we make errors as the project goes on, which means that we have to do more work to rework the errors that we already made. So it's not that simple number of tasks that have to be done. Some of those tasks have to be redone, and that's rework. That's in another model, also in the same link. Projects have many parts. This is just one mini project within a bigger one, and we can model each of those project parts, and those project parts depend on each other. So now we need to connect up these models to each other and say, well, what happens if project A in the big project overruns by 3 weeks, and that means that everything gets messed up for sub project B, and sub project C depends on those that go before it as well, and much more. And I should say here, project management of that kind is arguably one of the most developed and most extensive fields of application for system dynamics. It's been worked on for decades, and there are consultancy companies that specialize in system dynamics models of projects. And you can find more on that if you investigate this article that I'm showing on this slide here. Again, wait to download the slides. Don't try and copy it down now. Okay. So what can dynamic models add to system engineering efforts? Well, first of all, they do offer quantified simulation. An awful lot of what gets done in systems engineering projects is process mapping of what should happen. That's not telling you how things actually change quantitatively over time. As I say, it can and does, when necessary, merge both what's happening to the physical parts of the system, the development of the supply chain itself or the manufacturing system itself, with the organizational parts and the staffing and the products and services and what's happening to customers and what's happening to the financials. That implies that we can handle very wide scope. So we have got, for example, full organization, full business models. So in a single model, capturing all of those functions of the business in a single working entity. And an issue I'll illustrate in a moment is that it can deal with operational and strategic timescales in the same model. And in the process of doing that, it handles most of the causes of real-world complexity. It handles that stock accumulation thing, the accumulation of staff and the loss of customers and launches of products and movements of orders through systems. It captures interdependencies, it captures feedback, it captures thresholds when issues build up and reach a tipping point where something unexpected happens. So, for example, you might have enough staff to handle the number of customer inquiries coming into a call center, and you might continue to have enough for the next 6 months. But unknown at the moment is that there will come a point where that number of staff can't handle the growing number of calls coming into the service center, and then you'll get a tipping point where the quality of service that those customers get will kind of tip over the edge and get really, really bad. So let's dive into a couple of these in a bit more detail. I mentioned the comparison between process models and what system dynamics models do. My apologies, I've gone through this explanation in a previous one of these seminars, but there'll be people on this call to whom this is new. This is a very, very simple hiring process. You place job adverts at the left-hand side, you process the applications, receive acceptances, and when you've hired enough people, you stop hiring. If you haven't hired enough people, then you go back to the beginning and do another job advert. So there's a process map of a process, the hiring process. And note that all the activities in it are, the process diagram is capturing the activities that are done. They are all verbs. So hiring, issue, place, they're all verbs. They are things that people are doing, and they're all qualitative. They can be rigorous enough, but they're qualitative. They don't have any numbers on them. This is a system dynamics model of exactly the same process, where the elements in the model are now the nouns. So it is the applications that are going through this process, and we're tracking the numbers of applications going through the process, and they're quantified, and it shows how they're changing over time. You can go and play with this model yourself. You can see that we have to run 2 episodes of placing job adverts in order to get enough applicants at each stage to achieve the number of people that we want to hire at the end. But yeah, we need getting on for 40 people, and we nearly get there after those 2 hiring episodes. Now, I mentioned that system dynamics can handle multi-factor, multi-factor challenges and issues and plans, including those which deal both with the physical engineering of something and the managerial and financial things that have to happen as well, the staffing and so on. Now, this is beyond my pay grade. This is not something I've ever done or would claim the capability to do, but there are people in the system dynamics field who do have that capability and indeed have done it and regularly do it. So this is a link to a model from my friends at Copernicus Group in the Netherlands, and it concerns a large-scale project which was started off to improve the water quality in a large lake area, and at the same time create an opportunity for tidal power generation. So if you go to the short link that I've shown there, that will take you to the Copernicus web page that will explain that project, and there's a video showing how that was actually done. And that is a big model. It's a big project, and it needed to be substantial to deal with all of the detail and complexity of that large challenge. I'm not going to go through that slide because I'll leave you to read the detail in your own time. I mentioned that we can handle both operational timescales and strategic timescales. So what I'm going to just show you is a model that does that for a customer support staffing issue in insurance. So this is an insurance company that's getting customer inquiries coming in. It's got a support team, and if the number of customer inquiries goes up, then we need more support people to handle it. And this runs over a 3-year timescale, but there is a specific initiative happening there's a marketing campaign that's going to happen in that much shorter time window from September to December in 2020. Now, we want a model that can tell us both about that detail, what's happening over that marketing campaign period, and what's happening to the business as a whole over the 3-year kind of strategic timescale. So here is a version of that hiring pipeline that's configured for that service team. And we're looking at this in operational detail now. We're just looking at that, that 3-month period in weeks. And we've got 2 scenarios. The blue scenario is what would happen if we just did our normal hiring process. And the orange scenario is what happens if we say, we're doing a marketing campaign, customer inquiries will likely go up. We better increase our hiring to get more people in place. But how much extra hiring and over what timescale? What the model is playing out here is how many customers are being lost each day. So this is a daily model running over those 3 months, and what happens to the number of customers as a result of that marketing campaign. So in the larger chart at lower right, you can see, yes, the marketing campaign wins us lots of customers, but after that, if we do nothing, we start to lose some of those extra customers we won because service quality deteriorates. In the orange scenario, where we do something to enhance the service capacity by hiring more service staff, then the loss of customers does not decline so fast. Now, let's zoom out the timescale here. And now, instead of looking at it over 3 months, let's look at the same issue over a 3-year time period. Now, on the left-hand side, this is not one marketing campaign. You're looking at a whole series of marketing campaigns that happen over the whole of those 3 years. Every one of them does the same thing that the previous exhibit showed you. Every one of those marketing campaigns brings in a slug of extra customers and increases the demand on the service team, right? If we get poor service, then we lose more customers. So these charts are now looking at a 3-year timescale, and on that 3-year timescale, that previous slide is just one blip. It's a 1 3-month blip in that whole period, but it's one of many such blips. So if we don't have a solution that works every time we do one of these marketing campaigns, we don't just see a triggering of a customer loss rate once, we see it every time we do these things. And this may look like a small difference between the number of retained customers in the orange scenario, where we fix the hiring, and the blue scenario, where we didn't fix the hiring. But imagine what would happen if that applied to every one of the marketing campaigns on the left-hand side. By the time you get out to the end of year 3, you'd have something like 10 or 15% fewer customers, because we didn't engineer the hiring system properly to deal with those marketing campaigns. I'm going to run through this. You can read this in your own time. And I'll just kind of end here by saying that at the time I was working all this up with friends in the systems engineering field, it was about the same time there was a report published by the government business and industry department here in the UK, which was a computational modeling review. And the question asked was, to what degree could computational modeling help improve the strategy making and decision making across the UK economy, both the business sector and the public sector and the non-profit sector. And System Dynamics features in that. I don't think at the time that the reviewers actually understood quite the potential that System Dynamics has, but it certainly identified some of that potential for System Dynamics to help in strategic and decision-making challenges. And here are a few next steps. You can get the slides at the link I've shown here. Some people find it easier just to share short articles on these kinds of issues. So if you go to that the first of those 3 links, sdl.re LIP SESD1, it's the first of a group of 3 articles that say in a bit more detail than I've had a chance to do this afternoon, all of that stuff about what System Dynamics can offer for systems engineering. If you want to find out more about System Dynamics and its potential contribution for systems engineering, then there is a special interest group in the society. It happens to be called the Asset Dynamics Interest Group because that's very often a topic on which this expertise is deployed. But there are people there who know more than I do about how to do this. And then there are some other modeling resources that you can get from myself. So let me stop there and open things up for comments and questions and discussion.
Kim, do you want to take a moment to explain that discount that you just showed?
Do I want to explain what, sorry?
The discount on the courses.
Oh, yeah.
Briefly mentioned that, show that.
Yes. The courses I offer are they're great value, of course, absolutely fantastic value. But in case you find the ticket price a little higher than you might like, there is a 1/3 discount on those prices if you put that coupon code into the checkout pages.
So you can instantly download the slides that Kim just presented, and including all the links to the models. I just paste the link here in the chat. So if you click, you instantly download all the slides that you just saw. So Kim is gonna take a few questions. So I'm just gonna go ahead and let people raise their hands, or if you have a question, you can unmute yourself and ask directly to Kim. How does that sound? I think you had a question, George or Sam. No. Let me see if there's any question in the chat. No, more about the presentation. Yeah, so the people who ask about the slides, there's a link to download the slides. And that's about it, Kim.
I could ask a question.
Go ahead, Sam.
Hi, Sam.
Hi, Kim. I wonder, you said you worked with some friends in systems engineering. How do you compare, and where do you think system dynamics fits in a like a workflow for the model-based systems engineering? And I don't know a lot about it, but from my understanding, model-based systems engineering is kind of like a way of documenting a database. And so is that right, or help me understand that?
I think you may need an answer from people who know more about systems engineering than I do. But the direct answer to your question is you would do this right from the start. I mean, you do it before the start. The whole point of trying to produce simulations of this kind is to play out a future episode before it happens, so that you can bench test different assumptions, you can bench test different scenarios. You can say, well, what happens if this happens, if that goes wrong, or what happens if this thing goes better than we imagined. So when I'm as you know, Sam, I do most of my work more directly in business strategy and business challenges. So we build the model before the thing happens, and then we continue to use the model all the way through when it starts happening, when it's in the middle of happening, and right through to the end of it happening. And why would we do that? Because every event that happens, every experience that comes back tells you more about how the episode actually is working. So you won't get it exactly right when you're doing it ex ante, because there are things that you will have to estimate about the relationships in the system. But as soon as the system starts to behave, you'll get more information on that. So you update the model in the light of what real world information is telling you as you go along. If this is a thing that's never happened before, then go looking for proxies. Something like this will have happened before. So if you can, that can help you get your first prototype model of the initiative or the episode. That can help you get that better than it would otherwise be if you simply think about it from scratch, and consult widely among people who've done this thing before or been involved in this thing before. Get them involved in making the model better than it might otherwise be.
Thank you very much.
Okay.
George.
Kim, if I may, how are you?
Hi, George, how are you?
Fine. If I may try to complement the answer to Sam from systems engineering language, let's say. In systems engineering, people are usually concerned with modeling three types of things: modeling form, modeling function, and modeling emergent properties. So there are several different types of diagrams for modeling form, several different types of diagrams for modeling function. System dynamics will be more like modeling emergent properties, or in other words, the behavior that emerges from the functions. So that's a way to put into perspective from a systems engineering view. I think that's some of the folks here will be familiarized with that.
That's very, very helpful, George. And I should explain to everybody else that George is one of those experts in systems engineering who I commented on right at the beginning.
Thank you, Kim.
That means, of course, that George can answer any other questions that come up better than I can.
I try to help.
I see a question here in the chat from Sebastian Kim, and he's saying, "Thank you for your presentation. My question is, do you think that the system dynamics continuous time modeling presents limitation to elicit many, most of reality, discrete events?
Well, as you've seen with that insurance company demonstration, you can put discrete events. You can make events happen in a system dynamic model, but it will not capture the detail of what happens to every individual. So let's take that particular case and say, okay, we've done this marketing campaign, and it has led to an overload on the support team, and it does mean that we're losing customers faster than we otherwise would. It's not telling you which customers get the bad experience and which customers leave. It's just telling you that the customers in total are leaving rather more quickly than they otherwise would. So that is both a capability that the system dynamics model does have. It does capture the fact that episode will trigger the customer loss rate, but it is also demonstrating the limitation. It's not going to tell you that one of those customers you lose is the most valuable customer you've ever had, for example. It's not going to tell you that. I hope that answers Sebastian's question. If not, do come back, Sebastian.
I see, Carlo, you have your hand up. You want to ask a question?
I see a couple more on the chat as well. But let's hear from Carlo first. Hiya.
Hi, Karim. Nice to meet you, and it's been a pleasure to have this time opportunity to understand you better. Maybe a question from my point of view is, it's very interesting, for example, the analogy that you did before with the process modeling and the system dynamic behavior. How do you think is a challenge for a company that usually work in modeling stuff and they use KPI for measuring processes and measuring capability to switch the mindset in approach like that? That is, let's say, not easy to explain to the management for some point of view, and is also maybe complex to switch between a modeling where you have a lot of platform managing modeling processes to switch in this kind of mindset if you are not ready to be there quickly. How do you think? What is the challenge that you see in company?
Yeah, that's a very common challenge that all the people in the system dynamics field on this call will be very familiar with. I think what you have to do is you have to start with where people are, and avoid the temptation to come along with the grand solution to everything and say, hey, look, here you are, I've got the greatest model of everything that we need to worry about, and start by showing people, as I kind of try to do with that hiring process, to say, here is a model you already recognize, right? You will recognize that this is how we lay out the process of hiring, and you recognize, of course, that there are KPIs in that system. So we would be looking at a KPI would be, for example, what fraction of the job offers that we give to people who we screen through the hiring process, what fraction of those end up being accepted by the applicants, and which of what fraction do not get accepted. That's an example of a KPI that would come out of that would be recognized when you lay out that process diagram. But now you can say, well, here is a system dynamics model of exactly the same thing, and not only can you see that yes, that is indeed a KPI, but you can see what that KPI is actually doing in quantitative terms over time. So it's going to show you how the KPI will play out. So that's a big advantage. You can say to people that yes, your process model will show you how things need to work, but what it won't show you is whether it's all going to keep on working okay or whether things are going to go wrong. And if it does show you that things are going to go wrong, it also won't show you, a process model won't show you what you have to do, by how much and when, in order to fix the problem, or ideally prevent the problem happening in the first place. So that's Carlo, you'll get used to the idea that I give very long answers to longer answers to questions than I should. But that the short answer is you show them a system dynamics model that already matches what they already understand, and show them the added benefits they get from it, and then you go on to a slightly bigger issue and so on.
Yeah, personally speaking, I think that if you talk with the chief operating officer, maybe it's more interesting to ensure how this model can help in the capacity of the teams. This, I think, really provide a value probably for the team to understand how external dimension can change at the end the dynamic of the team, the department, the organization.
Yeah, indeed, yeah. Okay. Other questions here coming through, or should we take a couple more off the chat?
I do see one in the chat. Just a second, let me reopen this. I see a question from Marta. And Marta, I saw you unmute yourself. I'm not sure if you were about to ask your question live, but I can read it here.
Hi, Marta.
So she asked, do you find there are developing any generic models which are behaving like archetypes from which new models can be scaffolded off, often applied to a variety of common problems in business strategy, project management, marketing, etc.?
Absolutely. I almost never build a new model because I don't need to. That model I showed you of customer support capacity balancing against inquiries coming in from customers, you'll find that across, I was about to say all, but maybe not all, but a very large fraction of businesses. I've recently done a slightly extended version of that, which built in what happens with the customer onboarding process, where customers have to go through a number of stages in order to be brought on board to a customer's service platform. Customer onboarding structures are well known, very common, highly generic. You obviously have to tailor them to the particular case. But now we can lift the scope and say, well, actually, we've got generic structures for entire businesses. I've said this on one of these seminars before, but to illustrate what I mean, every table service restaurant in the world conforms to the same generic model. They all have a menu, they all have service staff, they all have tables, and they all have customers who use the restaurant more or less regularly, and they all make money by charging a price for the meal, which is higher than the price of the food items that they put together, and they make a gross margin on that, and they from that gross profit they make selling the meals, they have to take off the costs of their staff, and that gives you the operating profit. Every table service restaurant in the world fits that model. So yeah, there are generic models all over the place, which is great news, of course, because it means, as I say, you don't have to start from new models all the time.
Well, and also I'm thinking, Kim, from the perspective of people who are trying to learn what the value of the system dynamics approach is in context with like the systems engineer and the basic training that they've had in micro and macroeconomics. It is so daunting. I feel cognitively for, even Barry Richmond talked about the abyss between where we are and oh my God, here's system dynamics all the way over here. And I just think, how can we break down these cognitive barriers to encourage and give intellectual hope for people who they say, yes, this is clearly a benefit, but my God, am I going to have to go to school for the next 10 years? And how do I find a person who can do this? And that kind of, this is a real barrier, I think, to the huge dissemination. And I'm thrilled that there are the archetypes, and if it can get out to the public, that these do exist and that there are common patterns of behavior. I think it's a huge leverage strategy, I guess, if you will, to promoting this desperately needed a perspective.
Yeah, indeed, yeah, you're dead right, Marta. Many times, if I'm working with the general manager or the executive team, that they're very often, of course, concerned about what's happening to our profits or what's happening to our sales and how do we make our profits grow. So start with the income statement. So here's your income statement. Let's put the same items in a causal structure. It'll be a very trivial causal structure, but it'll show the revenue changing over time. It'll show the operating costs changing over time. It'll show the operating profit changing over time. And then you say, well, where does revenue come from? Well, revenue comes from sales and price. So how do they change over time? And you're
just
right.
break it down to the dominoes, and to be promoting that, marketing that orientation, I guess. You can't run before you walk in life, and I just think it's so helpful. It would give hope, confidence, familiar. It would ease stress. I think there would be so many emotional, benefits to just distilling out a sense of essence and being able to talk about big picture patterns that are widely spread, that can get you just over that initial hurdle to thinking, oh, I can system think. Oh, I can model. And oh, I see the benefit of it now. Blah, and off they go. Off they go. They got enough momentum then to keep them going to these next levels of understanding and benefit.
Indeed. Master, I might come back to you and build on that in a moment, unless there are other comments. I think I saw Paul had his hand.
I'm gonna give you two minutes to Paul. He has his hand up for a while now, and I think that's the last question we can take for this session.
Okay.
Paul?
Yeah, this is really a question for George, and I think you just answered it, George, in the chat. So maybe we can let it go. But you talked about form, function, and emergent properties, and that system dynamics might be useful for emergent properties, i.e. behavior. But I'm kind of assuming what you mean by form and function. I'm thinking of like a bridge or the title thing that Kim showed. So you could have multiple designs for that tidal gate that's producing energy, and those multiple designs would be different forms, I would think. The function is to produce energy. So it seems like in modeling, getting at what the emergent properties are, that is the dynamics of the behavior over time, you would also need to represent in the model the form and the function. So it's not just the emergent properties. So you have to am I on track here, George, or is that?
Oh, I think you're on track. And what I meant is system dynamics is a very powerful representation of emergent properties because it synthesizes all the rest. We have, by form, I mean what the system is physically. By function, I mean what the system does. And we have several different diagrams for representing both of those. And when we say design, we are referring to both form and function, but not necessarily portraying function over time, what we call behavior. When you do that, then we start to see flows and stocks.
Exactly.
As opposed to just seeing logic in a process map.
To get at the emergent behavior.
I think that's exactly what Kim explained.
To get at the emergent behavior, you have to represent the form, like what's the capacity that this design can handle, or what's the capacity this other design can handle, or the flows that they can handle, and the function is. So I don't know. Maybe I'm taking this too far, but it feels like all three would be involved in the modeling effort to get at the emergent behavior.
Yes, that's my understanding as well. But that's the reason why the system dynamics model requires understanding of form and function to be built.
Yeah, so it would be wonderful if we could get somebody else in the chat mentioned and Kim mentioned the systems engineering body of knowledge. There's a wiki out there. I put a link in, but basically it would be wonderful if we could get the powers that be in the systems engineering field to add simulation, more simulation, including system dynamic simulation, to the systems engineering body of knowledge. So I don't know if you have influence in those realms, but I would think that would be really helpful.
I'll go for it, George.
Definitely.
Well,
work on that.
Thank you everyone for comments and live discussion here. It's great to see everyone commenting and excited about the topic. And we have another one scheduled for 2 weeks, so it's October 16th. You can join us again here with Kim for the last webinar in the series, talking about critical research development with dynamic business models. I hope to see you here again. If you have any questions, you can also email me or Kim, and I'm gonna put here my email in the chat. We will share the recording soon, together with the slides and other resources that Kim shared today. Thank you, Kim, for another great webinar.
Okay, you're welcome. Thank you for joining us, everybody.
Thank you, everyone. Have a good evening. Bye-bye.
Fernando,
Yeah.
it comes to me that there are a lot of comments and unanswered issues in the chat. I don't know if we can capture those and deal with them.